Well, welcome back. We're going to talk about how to graph a conic and identify the vertices and foci of this particular one. I've gone through several on dealing with parabolas. Well, now we're going to look at something a little bit new, because here we noticed as we look at this conic, which is implicit form, is that we notice that we now have two quantities which are squared, both in x and y. Now, because both x and y are squared, we know it's going to be either an ellipse or a hyperbola. All right, an ellipse or a hyperbola. Now, there's a slight difference between the two, and when I mean difference, I think that really helps you out when you think about the difference. Because in an ellipse comes in standard form where you have a horizontal axis of x minus h squared over a squared plus y minus k squared over b squared equals 1. We are adding. A hyperbola, on the other hand, comes in a standard form of x minus h squared over a squared minus y minus k squared over b squared, and that equals 1. Where our major axis or our transverse axis is actually positive, but we are subtracting. Now here, we notice that my two values, or our two values, are both positive. Therefore, we're not talking about hyperbola, we are actually referring to an ellipse. So this is an elliptical. So in order to figure this out and to graph this conic, we're going to identify the vertices and foci, and also the minor and major axes to help us identify this, along with the center. So the first thing we're going to do is we're going to find the standard form. So with that, we're going to group all of our values together. So we're going to have 4x squared, and I'm going to bring that 16x, so all our variables together. And I'm going to have plus 25y squared, and I got 150y right there, and I'm going to subtract that 141 to the other side. Okay, from here, we want to complete the square not once but twice. Now to do that, we always want our coefficients to be 1, so I'm going to group this and group these two quantities together. Since I want this coefficient, our a value of our two quadratics, to be 1, this is not referred to this a value, just so you know I should use a different term. All right, but our coefficient, these are not the same, not the same, not the same. All right, but we want these coefficients to be 1. So I'm going to factor out a 4. When I do that, I have x squared plus 4x right here. And then I'm going to do the same thing here. I'm going to factor out that 25 because I want the coefficient to be 1 next to each one of these values. And that right here is going to be 6y equals 141. Now from here, we're going to complete the square by finding our c values. Now, once again, the c value that we're looking for is going to be opposite or b divided by 2 squared. So 4 divided by 2 is 2, 2 is 4. Now, to find this new value, whatever we do, algebra states, whatever you do to one side, you have to do the other. So now what we're going to do is we're going to take this 4, but make sure, this is a common mistake that students will do, is they'll just add 4 or not do that at all. All right, add just 4 over here. But we're not adding 4. We're actually adding 4 times 4 because we distribute that out. So 4 times 4, which is 16. Over here, we're going to do the same thing, find that c value, all right, by taking b over divided by 2 and squared. This case going to be 9. But once again, we're not just simply adding 9, we're actually adding 9 times 25, and we got that right there. So from here, what we're going to do is we're going to simplify this. And what we got is negative 141. We have plus 16. And this right here is going to turn into 175. Oops, no, not 175. Apologize. All right, this will be actually 225. Okay, we have 225. All right, so from here now, what we're going to do is we're going to add those values together. Okay, so when you take that, you can quickly do this, and we're going to take negative 141. And then we're going to have that right there and add 16 and add 225, and what we get is actually equals 100. So we have 100, which is a nice round number, and then we have 25, and we're going to just complete the square right away. y minus 3 squared, a little bit more room, and then we have plus, delete the square, 4, and we have x plus 2, that quantity squared. Now to go a little bit farther, we're going to now, in order to write our equation, if you recall, all right, we want this value, all right, one of the characteristics of this equation is that we want this value to equal 1. Okay, we want it to equal 1. So in order to make this equal to 1, we're going to multiply both sides by, multiply both sides by 1 over 100. 1 over 100, and make sure I distribute that through. So what I then have is x plus 2 squared over 25. So when you multiply right there, for hundredths is 1 over 25. And then we have y minus 3 squared over 4. And that equals 1. All right, so what we have is we have our equation. Okay, we have our basic equation that we're going to know and love. I'm going to simplify this, make it a little bit nicer. All right, and we have that right there. So from here, we want to finish this problem. We want to graph it and also identify our vertices and foci. Well, in an ellipse has 2 foci and also has 2 vertices along a major axis. The major axis is whatever value is larger. Okay? The major axis is the a value is always going to be the larger number. So a squared, so the major axis, you identify that, is whatever is the larger number of the denominator. So a squared always has to be greater than b squared. So right here, 25 is greater than 4, so therefore the x is my major axis. So I have a horizontal major axis. Okay, so when we do this, all right, we're going to have horizontal major axis. So I'm first going to kind of sketch my graph out. And after I find out my major axis, I'm now going to find my center. Okay, so the next thing is I want to identify the center. Now the center, you can see, is our h and k. So right here and here allow me to find the center. So we identify this center to be -2 and 3. Once again, the x with the x, the y with the y for the center. So we go -2, 1, 2, and 1, 2, 3. Now, I have to admit I'm not very good at drawing ellipses, but I'll do my best. Okay, so now from here, I'm going to draw this major axis, all right, just so I remember where to go. Okay, so here's my center. Now, next thing is the foci. Okay, the foci are c units away. But in order to write out actually what our ellipse is going to look like, we're going to use our a and b values. Okay, so we're going to find our vertices next. So the third thing is we're going to identify our vertices. Okay, the vertices are a units from center. Okay, a units from center. So what's our a value? So I guess the major thing is we got to find our a value. Well, in this case, our a value, all right, and we see a squared equals 25. Well, our a value has to equal 5. And that is from our major axis. We're going to go 1, 2, 3, 4, 5. So we have a point here. That's vertex 1, which we'll identify as 3, 3. All right. And then we're going to go 1, 2, 3, 4, 5. And that point's going to be right there. Move this over a little bit more. Over here. Okay. And 1, 2, 3, 4, 5. And then we got that point right there. We'll call this vertex 2, which is going to be at -8. Oh, sorry, -7. 1, 2, 3, 4, 5, 6, 7. Yep, -7. I'm sorry. -7. Can't count. -7, 3. And what we're doing is basically the a value, and we're subtracting it and adding it to our x value, because it's along the horizontal. Now, to finish this up, we want to find our b value, our minor axis, to graph it. So to finish our graph, we're going to find our minor axis. Okay? And our minor axis is b units from center. Okay, b units from center. Well, our b value, if you recall, is right there, our lower value. So it's going to be 4. So b squared equals 4. So b is going to equal 2. B equals 2. So from here, this is going to be my minor axis, which is going to be the vertical. And we're going to go 2 units. So 1, 2. All right, and we go 1, 2, and we have that right there. I can kind of draw this. And there is my ellipse, elliptical shape. All right, now the final thing we want to do is we want to find our foci. Okay, we found our vertices, and now we want to find our foci. Our foci are located on the major axis. Okay, and this would be the 5th thing, all right, that we want to find. Now the foci, okay, are C units. C units, all right, from center on major axis. Okay, on the major axis. So in order to figure this out, there's a special formula that we have to remember, all right, and know and love when it comes to ellipses. And there are proofs out there, and probably hopefully your pre-calculus teacher will teach you that. I'm not. I'm just assuming that you know this, so you shouldn't. But we have c squared equals a squared minus b squared. That's the equation we want to know, all right, know and love, and one of the key equations that you have when you're dealing with ellipses. Now, from here, we know c squared has to equal, well, in this case, a squared, which is 25, all right? And we're going to subtract the 4, which is b squared. So we find out c squared actually equals 21, and then c is going to equal the square root of 21. So our foci are going to be the square root of 21 units from the center. Now, it's going to be along this major axis. Now, if you take the square root of 21, that is approximately, all right, probably about just under 4 point something. So square root of 21, if you put it in your calculators, all right, 4.582, so about 4.6, all right, 4.6. So from here, we're going to go 4.6 units to the right and left. So we go 1, 2, 3, 4. 0.6 is going to be right there, all right. And then we can go 1, 2, 3, 4, right there, okay. And we'll write these 2 foci, all right. Where are they located? Well, we'll have this. We're going to take -2, and this is how we do it, plus and minus the square root of 21 to be exact, and 3 is going to be on the y-axis. So here are 2 foci. Foci 1, foci 2 are going to be right there, and here is our equation. All right, so that is what we just found. Okay, we found the foci, we found the vertices, we found the minor axes, and we also graphed it out. Okay, so foci, key thing to remember is the c value from center. Foci has a c in it, so it's c units away from the center. This little equation will help you identify that. The vertices, okay, are on the major axis, all right, and on their major a axis from the center. Okay, a vertices, and we have that. One other thing is we always want to identify that center. Okay, and you also want to write it out in this basic form, all right, depending on what we have. All right, so hopefully this helps you out. Finding ellipses can be very involved, especially when you're completing the square, but that's how we can do it. All right, and look for some other examples on how to solve conic sections in the future.